So in this video, I'm going to prove the sine rule, and the sine rule says the following: if you got a triangle ABC like this with the three angles ABC and the opposite sides are A, B, and C, well then the sine of A over A is the sine of B over B equals the sine of C over C. And there's two stages to the proof. We have to prove it for what's called the acute case and the obtuse case. The acute case is where the angle A here is an acute angle, and we're going to see in part B the angle A is an obtuse angle. Right, so the first step of the proof is to drop a perpendicular from C down to the opposite side. So there's a right angle there and there. And then what you do is, it's the sine rule, so we're going to have to get the sine of the angles here. So get the sine of A first of all, using the standard opposite over hypotenuse formula. So the sine of A is equal to, we'll call that side H, the perpendicular height, we'll call it H. So the sine of A is H over the hypotenuse, which is B, because the side B here is opposite the angle B. That's why it's called B. So it's H over B. And rearrange that formula and you get H equals B sine A. Now consider this right angle triangle over here. So get the sine of B. And the sine of B, if we just, sine of B is equal to opposite over hypotenuse again, which in this case, the sine of B is equal to H over A. Opposite is H, hypotenuse is A. And rearrange the formula and you get H is equal to A sine B. Now obviously both H's are the same. It's the same height in both cases, in both triangles, so those two are equal. So you put B sine A equal to A sine B, and then you divide both sides by AB. If you divide both sides by AB, it gets even neater, and the B's cancel here, and the A's cancel here, and you get sine A over A equals sine B over B. And as you can see, that's already the first part of the proof done, because the proof was sine A over A equals sine B over B, sine C over C. So we've got this first part done. Now, how do we bring in the sine C over C? It turns out all you have to do is get a different perpendicular. If you had dropped a perpendicular from B, for example, or from A, that would bring in, you could just do a similar set of steps there. So we don't have to go through them at all, we just say it. So you just say similarly, if you drop a perpendicular from C, for example, or from B, right here. So if you notice dropping the perpendicular from C, you got sine A over A, sine B over B. So C is left out in the formula. If you drop it from B, B will be left out. So you'll get sine A over A. Sine A over A is equal to sine C over C. And now putting the two things together, if sine A over A is sine B over B, and it's also equal to sine C over C, well then the three must be equal. So that implies that they're all equal to each other, that the sine of A over A equals the sine of B over B equals the sine of C over C. And that's it. That's the first part of the proof done. That's the acute case. Now we'll go on to the obtuse case. So the difference here with the obtuse case is that the angle at A is obtuse and the perpendicular height doesn't land inside the triangle. So when you do the perpendicular height, what happens is it lands outside. There's the height right there. And you have to draw a baseline to show even where it, just where it touches the baseline. There, we'll straighten that up. So we'll draw a baseline there. Now, so there's a right angle here this time. Now, we still use the same overall principle. We work with two right angle triangles. There are still two right angle triangles. There's this big one here, for example, all around here. but there's also a smaller one now, this one inside here. So the idea is we work with those two right angle triangles and get the sine in each case. One other thing you need to do is, that's the angle A, this is a straight line. So this angle in here is 180 minus A. We'll put that in first. So that's 180 minus A, because together they make a straight line. Now, work with the two right angled triangles. So first we'll work with this one here. So we'll work with the overall right angle triangle here. And I'm just highlighting it there for a second. We're going to get the sine of B for that triangle. So the sine of B is opposite over hypotenuse, which is H over A. So sine of B is H over A. So the sine of B is opposite over hypotenuse, which is H over A, which means that if you rearrange the formula again, H equals A sine B. Now do the same for the 180 minus A in the small triangle. So now we're working with this small triangle in here, just this one. So just work with this only and get the sine of 180 minus A. So the sine of 180 minus A is equal to the sine of 180 minus A is opposite over hypotenuse again, which is opposite, if you look at it here, is H over B. And rearrange the formula and you get H is equal to B sine 180 minus A. Now, the two H's are the same. That H and that H. It's the same height in both triangles. So those two are equal. A sine B is equal to B sine 180 minus A. Now there's one last step, one thing that's new here. If we revisit our quadrants for a sec, so just think about quadrants and think about the angle A and the angle 180 minus A in the in terms of quadrants. So if we go back here for a sec, if I put in an angle A here, and if I come over and by symmetry have the same angle A here, well then there's 180 minus A. So from there to there is 180 minus A. That'll bring you to here. And from our knowledge of quadrants and the fact that it's ASTC, so if we just put in the ASTC there as well, sine is plus in those first two quadrants. So there's symmetry there. So you from your knowledge of quadrants, you'll figure out that the sine of A is the same as the sine of 180 minus A. There's no difference because they're both plus in both of those quadrants. If you use your reference angle as A and work through your quadrants, you'll find out that they're the same thing. So to make a long story short, basically sine 180 minus A is the exact same thing because of symmetry. The sine of 180 minus A is the exact same thing as the sine of A. So we can replace that. So now we have A sine B is equal to B sine, that's just A now. They're exactly the same. So that has become that. And then the last step is the same as the first part of the proof. Divide both sides by AB. And now the A is gone on this side, the B is gone on this side. And there it is proved that the sine of B over B is the sine of A over A. And that's the proof done for the acute case and the obtuse case separately. And that's the whole proof done when you've those two done. So that's the end of the sine rule.